Okay, hello everyone. Okay, let's try to do a tutorial on this one. This is a paper. It's an Eastern Cape paper. I took this from I think it was on September. It's acid and base. It was question 7. Okay, so the question starts over here and then it goes to this part. So you can start with this part over here. Okay, the question comes like this one. They say it here: acid base indicator are generally represented by a formula which is HLN. Now the reaction of HLN with water can be represented below, which is over here. I'm going to write this. Okay, it's HLN plus H2O. Then it's going to give you the product of H3O plus Ln minus. Okay, I was just going through it previously. So as you can see over here, these two are the product, hydronium and this one, which means this is an acid, this is a base, this is an acid, this is a base. Okay, now they say it on a statement over here. They said that acid and base in the acid base indicators are generally are considered to be weak acid. They are considered to be weak acid. Okay, the question is, define the term weak acid. Okay, so what is a weak acid? So a weak acid, an acid normally it ionizes. It doesn't dissociate when you put it inside the water. So a weak acid is a substance that ionizes incompletely or partially, when dissolved in water. Or you can simply say it produces the low concentration of hydronium ions. So it's up to you how you want to explain this. Some can say, when it define this, an acid, okay, weak acid, sorry, this one was question 7.1.1. Weak acid is a substance that ionizes incompletely when dissolved in water. What does this mean? It means it produces low concentration or weak concentration of hydronium ions. Okay, so that is something that we call it a weak acid. Okay, I hope it's clear on the first part. Okay, so now to the next one on the question. They say it here now, 7.1.2. okay, is H2O acting as an acid or as a base in a reaction? So when we check our reaction, this one over here is our acid. Okay, this is our acid. Now H2O, which means now we'll be acting as a base. How did I know that? It's because now this one and this one, they are conjugate. Now this one have plus, which means have gained the hydrogen ion. This one have actually, this have gained. Now these have an excess hydrogen ion. You see the charge now is changed to become positive, it's no longer neutral. So now, which means when say is H2O acting as an acid or a base, in this case H2O 7.1.2 H2O is acting as a base. Why is acting as a base? It's because it has accepted hydrogen ion from this HLN acid. Okay, I hope you can understand. That's why it was only a 1 mark question. I hope it's clear when you see these things. Okay, so now the next question, 7.1.3. they say there, write down the formula, not the word, write down the formula of the conjugate base of HLN. So a conjugate, normally an acid, when it has donated hydrogen ion, is going to form a base. a base will form an acid. So normally it happens on an acid. When it donated, it forms a base. Like here, when you check this thing over here, they want the conjugate base, which means the conjugate base of this thing. So when you check here, this one is an acid. Now this should be the base, which means the base of this thing. This one have lost hydrogen ion. Now this one have hydrogen ion, which means this is a base, which means 7.1.3, 7.1.3. It's H. Sorry. No, that's a mistake. It should be L and minus. Now that is the conjugate base of this thing. Okay. Now the next question they said here, let's go through this one together. They said vinegar is a solution of ethanoic acid. Now we have ethanoic acid CH3COO. I hope you can see this one over here. It's CH3COOH. Now they said a certain manufacturer of vinegar claims that the vinegar she sells contain 5.80 grams. Now this manufacturer, they claim that this is the mass of of the ethanoic acid present in the vinegar that she's selling, which means there is a person who's selling vinegar, and when she's selling that vinegar, they claim that inside the container there is the mass of 5.8 grams of ethanoic acid. I hope it's actually clear on this part. Okay, now they say here, they say 5.8 grams of ethanoic per 100 milliliter vinegar solution. So 100 milliliters is the same as 100 centimeter cubes. Those are the same thing. Okay, so now they say here, a group of learners used the apparatus shown below to test the claim by the manufacturer, which means they were trying to check if this thing is true or not, which means what they normally did, they prepared something. They told us here, a group of learners, they tried to do this thing to prove whether is it true or not true. Now they titrated a dilute sample of vinegar against a standard sodium hydroxide, which means they took the dilute sample, which means they took diluted CH3COOH, okay, of vinegar against the standard sodium hydroxide, which means sodium hydroxide were given the concentration, and they said for the concentration of sodium hydroxide is 0.1 mole per decimeter cube. I hope you can see the question over here. Okay, now after that, now they took this one, this indicator, however, they took hydrogen, I think it's Nina, I don't know what this is pronounced, but it's HLN. They took this one and they use it as an indicator, as they told us over here, as the acid base indicator. Okay, now they gave us the balanced equation. Now we have sodium hydroxide in solution, and this one in solution, and they have this as our salt, okay, in solution, and we have we have H2O, and now that is water. Okay, so now here, the first question they said over here, hope you can see the question. On the first question, they said, they said over here on the first question, this one, they said here, write down the name of apparatus X. Where is X? This over here. Okay, now this is how titration is done. This one, they put the burette. This over here is the conical flask. It is stopcock. Then inside, normally they put the base. Then inside the burette, they put the acid. As I took some notes, they also put the acid inside here. Why they're doing that is because the base is soapy. Okay, since soapy, so it's going to cause the blockage over time. So the acid is so light, they just put it inside here so that it's going to be easy when they do the mixture. Okay. Now for apparatus X, this one is a burette 7.2.1. Okay, 7.2.1. It is a burette. Okay, this is a burette. Okay, now here this apparatus is a burette. Now 7.2.2. Now use the equation. Use question 7.1. Raise 7.1. This equation over here. It's okay. Use equation 7.1 to determine the color change that will take place at the end point. So normally at the end point is where the number of mole of acid is equal to the number of mole of a base, which means now at the end point, this is when we have fully neutralized a certain sample, or a certain sample, like an acid or a base. We normally call it an equivalent point. So now the ratio mole at that point, they are equal. Okay, so they want us to determine with the color change from pink, from pink to colorless, or colorless to pink. Okay, let's check here. Okay, so we know this one is what? So now we have added this. Okay, what are we doing here? We are adding an acid to this thing. We are adding the acid to this thing. We have an indicator inside here, which is this HLN. And now we are adding the acid. Okay, we are adding the acid is going inside here. So what is going to happen? So the first thing that you need to know is that I'm going to answer this 7.2. I want to say this: when you add the acid, you are actually increasing what? The hydronium ions. Let me write this down. I'm CH3COOH and then plus H2O. Right, so you're going to find that the product is going to be CH3COO minus plus your H3OO plus. Okay, so when you check here, when you add the acid, you are increasing the concentration of what? Of hydronium ion. I hope that is clear. So now, since you are adding the acid, now as they've said over here, use Lechete's principle to explain the answer. So for me to explain that for you, one thing we know about Lechete's principle, when you add the product, more reactant will be formed. Okay, which means the opposites also take place. When you add the reactant, more products will be formed. So in this case, what are we doing? So now in this case, we are increasing what? The concentration of the product. I hope it's making. We are increasing the concentration of the product. Now this thing is increasing. So when this thing is increasing, I can even do the graph to explain this thing. So now the concentration of this is increasing, which means for the product. So now when the concentration of this thing is increasing, which means the equilibrium will lies to the left. We are adding more product, which means the equilibrium will lies to the left, which means as we have more of this, the color should change from pink to what? To colorless. Again, the color should change from pink to colorless. Why? It's because we are increasing sorry we are increasing the color, so we're increasing the concentration of the hydronium ions. I hope it's making clear. So the answer here, the possible answer here, it's pink to colorless. Okay, which means 7.2.2 pink to colorless. Okay, I hope it's actually making clear. Okay, can I drink water? Okay. Okay, thanks. Okay, so now here to explain this, because they said use the Lechete's principle. Okay, as I've drawn this equation over here. So now adding, when you add, okay, I'm gonna write the bullet. When you add, okay, acid in a solution, okay, you increase concentration of H3O plus. Okay, so now we are increasing the concentration of the hydronium ions. So when the concentration of hydronium ions increase, which means the equilibrium, because I'm using Lechete's principle. Now equilibrium will now there will be a re-establishment of the equilibrium, which means equilibrium will re-establish. Equilibrium will re-establish and favors the reverse reaction. Same thing. So when you, in another way, you need to know this thing, some general note. When you add the acid, you increase the concentration of hydronium ion. But when you add the base, you decrease the concentration of hydrogen ion. So I hope it's making clear. So now, which means now the equilibrium will reestablished and favors the reverse reaction. Okay, so once you have explained that thing, what does it mean? It means it will shift to the left. Okay, now there will be a shift of the equilibrium. It will shift, or you can simply say it will shift to the left. Mean more product, meaning that more product, more, I mean, not more products, meaning more reactant will be formed compared to the product, which means more reactant will be formed, or let's put the word produced. Okay, more product, more reactant will be produced, since now the equilibrium have shifted to the left, or it favors to the left. So now the color here should change from what? From a pink to colorless. Okay, let me write the equation again. Equation again is going to be HLN plus H2O. Then the product over here, this one is like this, which means H3O plus Ln minus. So now this was pink, this is colorless. So which means now we have more of this, the product, which means now it has to lie to the left, which means the color will change from, because we're producing more of this. Since we're producing more of this, we have increasing the concentration of this one, which means now the equilibrium will shift to the left. I hope it's clear on this one over here. Okay, so now the next question, it was based on this paper over here. Okay, so the next question, they said 7.2.3. They said here, okay, take the paper. They said calculate the pH of sodium hydroxide solution before the titration. When you remember, they gave us the concentration. They said the concentration is 0.1. So now, since we are doing for a base, we need to remember the Kc value of the hydronium ion in water proteolysis. Okay. When you remember, according to water proteolysis, the Kc, or we normally say Kw, is equals to 1 times 10 raised negative 14. Equation, it comes like this one. So this one, we already know that this, it gives you for what? For the concentration of hydronium ions plus the concentration of what? I mean, not plus your OH minus. I hope it's making sense. So when you multiply the concentration, you have to get this one, because this and this, they are both almost the same inside the water molecule when they are only undergoing autoprotolysis. Now, what do we know? We know the concentration of this one. Okay, we know the concentration of what? Of a base, with the sodium hydroxide. Why I'm taking the same thing is because this is a strong base, so it's going to dissociate completely. Again, it's NaOH. Okay, so now this one we're gonna put in water. We don't write it down here. Why? It's because it doesn't form an ion, it's only dissociate. So which means it's going to be Na plus your OH minus. Now, for every 1 mole of this per unit volume should be the same as 1 mole of this per unit volume, because this, it dissociates completely. Okay, which means what you're gonna do in this part over here, once you know the concentration of this one, already know the concentration of this thing, because it dissociates completely. Which means we're gonna say 1 times 10 raised negative 14, and then sorry. Sorry about that. Which means okay, which means 1 times 10 raised negative 14 is equals to H3O plus, and therefore, and then it should be OH minus. Okay, we know the concentration of this one, it's 0.1, which means over here it's going to be 1 times 10 raised negative 14 equals to H3O plus. Okay, then here we're gonna put 0.1. Okay, so this divided by this, you're gonna find that our hydronium ions have the concentration of let me take the calculator. You should get we're gonna say 1 times 10 raised negative 14 over 0.1. You're gonna get 1 times 10 raised negative 13. Now this is a concentration. Then when you're done, you're gonna take the pH. You're gonna say pH is equals to negative log of H3O plus. Okay, therefore negative log, and therefore which means going to be 1 times 10 raised negative 13. Okay, and therefore you're gonna say here negative log of the 1 times 10 raised negative 13. Okay, then we're gonna get the value of 13, which means the pH over here, it is 13, which is true, because when check the scale from 7 and above, you're gonna get 7. This side is something that is basic. Now it's weak, and close to 14 it's strong. And when you see sodium hydroxide, it is what the strong base. Okay, now I hope that was clear. We're trying to answer this question over here. Okay, now let's go to the next question. So what is the next question saying? Okay, so the next question comes like this. They said here, they said over here, okay, they said the dilute solution of vinegar used in a titration was obtained by adding 10 centimeter cube. Sorry, I was reading this before. It's 10 centimeter cube of vinegar of water and filling up to a volume of 100 centimeter cube. Which means, what does this mean? It means there was what? There was 10 centimeter cube, okay, of what? Of ethanoic acid CH3COOH. Now what they did, they diluted this thing. The moment they diluted this thing with water, the volume changes. This was 10 centimeter cube. This is the concentrated one. Now the diluted one is 100 centimeter cube. Now, which means this is what they normally did in this. The dilute solution of vinegar used in a titration was obtained by adding 10 centimeter cube of vinegar to water and filling up with water to a volume of 100 centimeter cube of dilute solution, which means now the one they were using in a titration was 100 centimeter cube, not 10 centimeter cube. But one thing you need to know when they talk about the dilution, CV equal to CV. Why we say this one is for undiluted for the diluted? Why are we using this equation? Why we say these two are the same is because the number of mole inside the container are still the same. But the only thing that is changing is the concentration and the volume, but the number or the particles inside the container is still the same. Okay, now they say there during the titration they have 18 centimeter cube of sodium hydroxide. Solution concentration of this one neutralizes exactly 20 centimeter cube. Okay, that 20 centimeter cube was neutralized used by 18 centimeter cube of diluted diluted vinegar. Okay, which means 18 neutralizes this one. Okay, so what is the most important part here? The concentration of these two is the same, because for example, if we're gonna have 2 cup, okay, if you're gonna have 2 cup and you make a juice over here, and after maybe this you make a juice over here, then you take the juice and pour a small piece over here. My question is, will these taste the same or not the same? It will taste the same. The concentration is the same. The concentration of this 20 centimeter cube and 100 centimeter cube, it should be the same, because it's the same thing. The only thing they told us that 18 of this neutralizes 20 centimeter cube of this one, but the concentration of this 20 centimeter cube is the same as the concentration of this 100 centimeter cube. Okay. Now over here, determine by calculation whether the manufactured claim is true or not. Okay, let's try to do the calculation. So what are we trying to answer here? We are trying to answer this question over here, where they said that we have 5.8 0 grams of ethanoic acid. That now this mass is present for every 100 milliliter of what of vinegar solution. We are trying to prove whether is this thing true or not true, which means our job, let's try to get the concentration, the concentration of this undiluted solution. Once we get the concentration, then we calculate the mass of that thing, because it's going to tell us for every 100 milliliter cube, because now we've already know when it's diluted, because we can able to calculate the concentration of what of the diluted. Then you're going to go back using this equation and try to find the concentration of an undiluted. Then we're able to get the mass. I hope it's making sense. Okay. So which means what we need to do, our first step, let's write down the equation of this titration. So what are we trying to titrate in this equation? We're trying to titrate the solution, which says it's sodium hydroxide plus CH3COOH, okay? And therefore the product here is going to give us the product of the product over here. We have salt, okay? It's going to be CH3COONA plus your what? Plus your H2O. This one and this one will form water. I hope it's clear on that part. Okay. Then the next thing that you want to do, you want to try to work out the information that is given. So we have the concentration, and we have the volume. What do we need to do? We need to try to calculate the number of moles. Then we'll be able to get the numbers of moles of this one over here. Once we know the number of moles of this one, then we'll be able to work out the concentration. Okay. Which means the first step, let's get the number of mole, because the ratio mole it's 1:1. Okay, so now after that we're gonna say here C is equals to N over V. The concentration is 0.1, and therefore equals to N, the volume of this sodium hydroxide. They said 18 centimeter cube of this one, which means it's going to be it should be, when you say 18, because converting that to decimeter cube, is 18 divided by 1,000. It's gonna give you 0.018. Then you cross multiply, and therefore you're gonna find that the number of mole is equals to, number of mole should give you 0.1 times 0.018. It's going to give you 1 times 10 raised negative 3. Okay, it's 1 times 10 raised negative 3 mole. I hope it's still making a sense on this one. Okay, so now the next thing that you actually want to do, now you have the number of mole of this one, which means once you know the number of mole of this one, use the same number of mole of this one. When you know this number of mole is used to neutralize 20 centimeter cube of this one, but the number of mole should be the same because it has neutralized. Okay, what would that mean? Which means the next thing that you want to do, now we know the number of mole of CH3, which means CH3COOH has the number of mole of 1 times 10 raised negative 3 mole. Okay, now let's try to work out the concentration of this one so that we're able to determine the concentration of this 100 centimeter cube, because it's a diluted one. You're going to do the same thing. C is equals to N over V. Concentration, we are looking for it. Okay, so which means our next job, we're going to say 1 times 10 raised negative 3 divided by the volume. The volume here, it was given that the volume is 20 centimeter cube, which means we're going to divide that by 1,000. It's 20 divided by 1,000. You're going to get that it is 0.02. Then you're going to calculate the concentration. It should be 1 times 10 raised negative 3, over 0.02. You're gonna get that it should give you I think I've made a mistake here. Sorry, I think I've made a mistake. 0.1 times 0.018, it gives you 1.8. I've made a mistake here. It's 1.8. Sort of, guys. it's 1.8 over here. Okay, it's 1.8 times 10 is negative 3 over here. It's 1.8. Sorry, my bad. Sorry, it's a mistake. 1.8 times 10 raised negative 3. Okay, I think I've made a mistake over here, my calculator. Okay, which means 1.8 times 10 raised negative 3 over 0.02. You're gonna get that the concentration of this thing is 0.09 what mole per decimeter cube. Okay, so now we got the concentration of this 20 centimeter cube, but this and this, they're both undiluted, so the concentration of this thing is the same. So now our job is to try to work out what, let's try to work out the concentration of undiluted, because now we know this one has a concentration of 0.09 mole. Let's work out the concentration of the undiluted. So we're going to work out using this formula. C V for undiluted is equal to C V for diluted, because the number of mole are the same. This is 100 centimeter cube and this one, so the number of mole are the same, which means the concentration of undiluted, we are looking for it. Okay, we are actually looking for the concentration of the undiluted, which means our job, we're going to say C, the volume for undiluted, it is 10, which means it's going to say 10 divided by 1000. 10 divided by 1000 is going to give you 0.01. Here is going to be 0.01 equals to the concentration of the diluted one. It's 100, which means it should be 0.1. The concentration is 0.09. The concentration we've calculated over here, it should be 0.09. Okay, then the volume over here, we know that the volume is what it is. The volume for the undiluted is 100, so it's going to be 0.1 because it's 100. We're trying to convert this from here to that part. Then you're going to divide by 0.01, which means the concentration C is equals to, we're going to do it like this. You're going to say 0.09 times 0.1 over 0.01. You're going to find that the concentration of the undiluted, for the undiluted, it is 0.9 mole. 0.9 mole per decimeter cube. Now we know the concentration of the undiluted. So what is our next job? So our next job that we need to do, we need to work out we need to work out the mass of this thing. That how does it weigh? The mass of these things in grams, so that we're gonna compare with that 5.8 that the manufacturer claims. Okay, which means the next job is simple. You're gonna say use this equation as C is equals to N over V, and therefore N is equal to M over M. I'm gonna blend these two. I'm gonna put this instead of N, I'm gonna put M over M, which means when I took this over here, the formula should come like this. It should be C is equals to M over VM. Okay, it should be a VM or MV. Let me just use MV so that it makes sense. So there's this equation come from this one. I took this and put it over here. This will go below, this will go at the top. So it's gonna give you something like this one. I'm looking for a mass. The concentration of that undiluted, we've calculated that the concentration is what? It is 0.9. We are looking for the mass, okay, over the molar mass of ethanoic acid. I'll do it over here. The molar mass of ethanoic acid, it's CH3. It should be it's CH3COOH. Okay, carbon is 12 plus hydrogen, it's 1 times 3 plus carbon is 12, oxygen, there are 2 of them, which means plus 16 times 2 plus 1. Okay, so when you do the calculator over here, it's going to be 12 plus 1 times 3, okay, plus 12 plus 16 times 2 plus 1. Okay, it's going to give you 60, which means the molar mass of this thing is equal to 60 grams per mole. Okay, so now we know the molar mass of ethanoic acid. Okay, so which means our job, we're going to say open brackets, we're going to write 60, and therefore the volume is 10, right? So it's 10 is going to be 0.01. Okay, so now let's try to work out the mass with this concentration. It's going to be 0.9 times, we're going to cross multiply 0.9 times 60, and therefore times your 0.01. You're going to get that the mass is what? You're going to get the mass of 0.54. Okay, get the mass of 0.54, which means when you check this thing over here, sorry, so I would say that it should be 0, okay, which means now when you do 0.9, okay, 0.9 times 60 times 0.01, okay, 9 times 60 times 0.01, you're gonna find that it is, sorry, you're gonna get you're gonna find that the mass is here, it's what, it is 0, sorry, my bad, you're gonna get 0.54. okay, this one is for what, is for every volume of 10 centimeter cube, which means for 100 centimeter cube, which means we're going to change the value here and put 0.1. When you put 0.1, we're going to find that it's 5, this is grams, 5.4 grams for 100 centimeter cube, which means for every 100 centimeter cube, we find that the mass is 5.4. As you can see here, 0.9 times 6 times 0.1, which means for every 100 centimeter cube, this is a mass, because for every 10 centimeter cube, you're gonna find that it's 0.4, but for every 100 centimeter cube, it's going to give it the mass of 5.4 grams. So which means this vinegar contained the mass of 5.4 grams, which means when you check here, they said it contains 5.8 grams, and we got 5.4, which means the information is not true, which means we're going to say therefore this is not true, because the mass is 5.4, it is not 5.8. Once again, guys, thanks for your time. This was a good question. Still going to upload more. I'm still going to come up with a lot of lessons. I've did this one because there was a bit of a challenge in terms of the calculation. You need the big and a good understanding out of the essence-based foundation. But so far, thanks guys for your time. More content to come. It's still Boss Move Academy, Mr. Garber. Thanks for your time.